Okay, guys, welcome to our next lecture. Uh, so we are done with the Zumo robot, and now we will move to a new topic, which is programmable logic controllers or PLCs. So the first question is, what exactly is a PLC? So up till now, for most of your semester projects, you have been using things like an Arduino or maybe a Raspberry Pi. But when you work in the real industry, then the requirements are very different. You need higher temperature, you need to work with higher current, so machines use several amperes. uh, Machines are running 24/7 every single day, and there are also power fluctuations. Um, so based on all of these requirements, you cannot use a simple device like an Arduino, but instead you need something like a PLC. So this drawing is not to scale. The Arduino is much smaller than a PLC, but a PLC looks something like this. So what are some example tasks for PLCs? Let's say traffic signals, these use PLCs. A car washing booth, they also use PLCs. Many factories such as bottling plants, if you need to fill liquids and put caps, if you want to automate all of that, then you need a PLC. And there are countless other examples which you can find online on YouTube. So let's take a look at a basic example of car washing. So everything starts from this point, from the left side of my conveyor belt. So I have a start button and a stop button. When I press start, the conveyor belt will start, my car will move, it will reach this stage, and then an actuator, so some motor will run this sprinkler. After some time, the car will continue, it will go through a brusher, again it will go through a water sprinkler again, and then a dryer. So there is a large number of processes which is happening, all of which can be controlled by a PLC. But let's break this down. So at each stage, I need to detect if a car is present. So let's say I use an ultrasonic sensor for that. So that would be considered an input. I have a start button and stop button. So those are also my inputs. Then I have some motors which are running these different brushers or dryers and these sprinklers. So those would be my outputs. Then I will be connecting all of these inputs and outputs to a PLC. Um, so the PLC is basically my controller. Lastly, I need a computer to program my PLC. So these, so these four different things are what are used in an actual automation process. So if we look at this block diagram, we can see that I have input devices, I have some output devices, this is my PLC. Obviously I need to provide power to my PLC so that it can run, and then to program my PLC I will be using some software. So if we look at a PLC close up, it looks something like this. You can see here I have I/0, I/1. If you can't see it, then zoom into this PowerPoint file as you go along. So this I represents an input. So here I have 6 different inputs. I have some outputs. So again, I can use these different outputs. I have a power cable to activate my PLC, and lastly, to program it or connect it to a computer, I have a programming cable. So if we take a look at this car washing example, the start and stop button will be connected to an input over here, and all of these actuators which are connected to these different devices will be connected to a output terminal. So also notice that these wires are also quite thick and these connections are very secure. So this again just tells you that the PLC is much more robust and more applicable in industrial applications. So some history, PLCs are quite old, but even though they are old, they are still used in several industries. I myself have worked in a few different industries, and all of them still use different PLCs for all of their processes. So PLCs work on a relay logic system. Uh, I will explain that, and we'll see that in the coming slides. So let's see how this works. So I'll just show you how the programming works uh, by briefly going through it. So this is a small PLC program. You don't have to understand how it works, but just follow along with the logic. My signal will start from this particular point. So let's number these different rows. So this is row number 1, this is row number 2, and this is row number 3. So what happens is my signal will reach this point and first go through row number 1. This switch is open, so the signal will not pass, therefore this connection is closed, and my output device will be off. Then my signal will go through row number 2. Here is some contact or some input. Again, this is open, no signal will pass, this output is also off. Lastly, my signal will go through the third row, and this contact is closed, which means the signal or the power flow will go through here, and this lamp will be on. So this is how a PLC program works. This is a column, so this whole thing is a column, and these are different rows. So row number 1, row number 2, and row number 3, also called networks or rungs. But I'll explain that in the next lecture. So let's see that as an animation. So my signal is here, contact is closed, this is off. My signal again goes through here, contact is closed, but my signal goes through the last device or the last row and turns on my lamp. So this is a very basic example of a PLC program. Okay, so again, this is just another block diagram showing you that this is your PLC. You have different inputs which you can connect and different numbers of outputs. So for inputs, you can have different things such as push button, limit switches, analog sensors, relay contacts. So some of you might have already used these sensors in projects before, so this should be nothing new. Output devices, you can have relays, you can have LEDs, you can have alarms, motors, solenoids. Again, the same outputs which you use in your Arduino, you can use over here for industrial purposes. And to program a physical PLC, you connect that PLC to a computer. There is some PLC software which we will look into, and by using that software you can program the logic. So let's take a look at some practical example. So this is a tank and it has some liquid inside. So I open the valve and some liquid flows. I have a pressure sensor switch, a temperature sensor switch, and a manual push button. So the objective is the mixer motor should start when the temperature and pressure reaches a preset value. The other option is the motor should start when a push button is pressed. So I have two conditions. Either this condition should be true or this condition should be true. So if I look at the PLC programming, and again, you don't have to understand this logic precisely, you should just have an idea. So let's take a look at this example by using the same logic. So my code will start here. This switch is currently off, so nothing will happen over here. My signal or power flow will come here. Now if I press this push button, then the contact will be closed. So if the contact is closed, that means this path is closed. So my signal will pass here, the path will be complete, and my motor will turn on. Now, if my temperature and pressure sensors both reach their respective conditions, this contact will be closed and this contact will be closed. So my signal will pass through this circuit and my motor will be on. So the signal can either pass through this point or this point depending on the particular condition. So this is how a PLC program works. It scans through each network very fast, so PLCs work very fast, and based on the condition it takes that path. So now again, in a real life example, this switch and these sensors would be connected somewhere over here, and this motor over here would be connected to my output device or my output terminal over here. So these particular symbols, which we will again look into once we start the programming, these are called instructions. So this is what we call a normally open contact. It's currently open, but when the condition is true, the contact will close and the signal or the power flow will go through this particular point. So we have 1, 2, 3, 4 different instructions. This is an output and this is an input instruction. We also have addresses. So just like your Arduino, you have D1 or D2 or A0 or A1. In the same way, you also have addresses for inputs. So again, the same thing over here. So these are just two instructions which we see over here, an input and an output. But the PLC is a very powerful tool. You can use different things. For example, you can use a timer. So let's say after I press a button, the motor should run after 5 seconds. Or let's say in the case of a counter, once I have processed putting a cap on 50 bottles, my PLC should close. So in order to keep track of that number, I can use a counter. I can also do different things such as mathematical expressions or comparison operators. So again, there are so many different options, and we will look into this in the coming labs. We have different classifications of PLCs. For example, small PLCs. Small PLCs obviously will be cheaper, but you have less I/O pins. You can have bigger PLCs, more inputs, more expensive. That depends on your application. Okay, so I hope this introduction of PLCs was good enough. If you are still confused, you can again look at YouTube videos. It's quite easy to understand if you watch some physical example of some PLC application. So we don't have any hardware because we are conducting this lab online, but we can use a software to simulate a PLC. So this is a link to the software. I will also include this in the Google Classroom. I think this is about 300 MB, but this is a very good software because you can actually simulate actual PLC processes and do programming on it. So I have the program installed. So it's called Do More Designer. So I'll click this, I'll go on my Do More Designer, and this may seem confusing, but I'll explain all of it in the coming labs. Right now, on the side under applications, we have simulator. So this will simulate an actual physical PLC. If I double click this, a simulator opens up, and it comes with many different things. This is for providing power to the PLC. So if I stop this, my PLC has no power, nothing will run. If I put this on run, you can see that run opens and power is provided to my PLC, which means I can actually do some programming and observe the simulation. DI stands for digital inputs and DO stands for digital outputs. So let's say, for example, in the case of this mixer problem. Let's say I want to simulate a temperature sensor or pressure sensor or a manual push button. I can do that by clicking this button. So if I want to test this particular logic, uh, I can simulate the push button by pressing X0. And let's say I want some output to be on. So I'll press X1, Y1 turns on, and Y2 also turns on. So I can turn on outputs obviously through the programming, but the point is to show you that uh, you can actually simulate PLC processes by using this simulator. So the actual programming is something which we have to do. So we will be making programs like this, but for the time being, for this lab, just try to understand what PLCs are used for, and just understand that we have a simulator which can simulate uh, different processes depending on our program. So again, we also have timers, we have counters, we have analog inputs and outputs. So this is actually quite a good software to understand PLCs, even though we don't physically have one right now. So that is it for this lab. I have explained the basics about this simulator, but we will cover this in detail in the next lab. So that's it for this lab, and if you have any issues with the software installation or whatever, then you can just message me on the Google Classrooms or on the WhatsApp group. So that's it for this lecture.